Alright, so what we're going to do today is we're going to take what we've done with limits and apply it to how it can help us find asymptotes of our graphs. So some things that we are going to look at today are domain and asymptotes, as well as finding zeros. So what we're looking at is rational expressions. So this first one here, that's considered a rational expression because it's a polynomial on top and bottom. So if you remember, to find our domain, you take the denominator and you set it equal to 0 and you solve. So if we take our denominator here, x plus 3, set it equal to 0, we get -3. That means that's the value that x cannot be. So we would say our domain is all real numbers except x cannot equal -3. Another way to do it would be interval notation. So if you did it in interval notation, it would be -infinity to -3 in union with -3 to infinity. I would take either one. Interval notation is great practice, but if you'd rather write all real numbers except x cannot equal -3, that's fine too. Okay, then we're also going to look at finding our vertical asymptotes. So for vertical asymptotes, you set the denominator equal to 0 and solve. Now, one of the differences between vertical asymptotes and domain, vertical asymptotes is after you simplify. Domain is before you simplify. So domain is the first thing you want to do. Then you try to simplify if you can, and then do your vertical asymptotes. So with this one, we can't simplify anything, so we actually get x equals -3 as a vertical asymptote. Okay, that doesn't always happen. It only happens when you can't simplify the original equation. Lastly, we have horizontal asymptotes. A horizontal asymptote, you find the limit as x goes to infinity of your function. And that'll give you your horizontal asymptote. So here, if we take the limit as x goes to infinity of 1 over x plus 3, what do we get? So at the end of class yesterday, I had shown you guys, or today if you're watching it today, the shortcuts for limits to infinity. This is where you'd want to use them to help save you some time. So this one is bottom heavy because the degree on the bottom is 1, where on top it's 0. So when it's bottom heavy, your limit is 0. So our asymptote will be y equals 0. So for right now, we're just finding these pieces of information. Tomorrow is when we're going to actually put them onto a graph, or I'm sorry, on the block day is when we're going to actually put them onto the graph. So today we're just practicing finding these things so that when we go to graph, we just focus on graphing and not the finding of all these things. Okay, so we're going to do 2 more here, and then I have a couple more in class where all we're doing is finding the domain, the vertical asymptotes, and the horizontal asymptotes. So if we look at this first one here, we set the denominator equal to 0, so 5 minus 2x equals 0. We get x is equal to 5 over 2. So we can say that's what it cannot equal. So negative infinity to 5 over 2 in union with 5 over 2 to infinity. And again, if you'd rather write all real numbers except x cannot equal 5 halves, that works too. Now, when it comes to simplifying, I can't simplify or factor and simplify my rational expression, so that means my vertical asymptote is going to be at 5 halves. X equals 5 halves. And then lastly, we take the limit as x goes to infinity of 7x over 5 minus 2x. So again, I'm going to try using our shortcuts. So I have the same degree on top and bottom. The top is x to the first, the bottom, the highest is x to the first, which means there are coefficients, so 7 and negative 2 would be the ratio that gives me my horizontal asymptote. So the horizontal asymptote would be negative 7 over 2. All right, so if we look at number 2, so again with domain, before we simplify anything, we start with domain. So I have x squared minus x equals 0. I'm going to factor out an x, and I set each value equal to 0 to find the x's. So I get 0 and 1. So my domain would be negative infinity to 0 in union with 0 to 1 in union with 1 to infinity. Or if you would rather write all real numbers except x cannot equal 0 and 1, that's fine too. I'll take either one. Okay, so then it comes to simplifying. So I'm going to look at my factored form here. I don't see anything in my factored denominator that would cancel. So this is an example of one that will have two vertical asymptotes. It's going to have a vertical asymptote at 0, and it's going to have a vertical asymptote at 1. So we have to include both. And then lastly, for our horizontal asymptote, we find the limit as x goes to infinity of x plus 3 over x squared minus x. Let's see, so I have my highest power on top is 1, on bottom it's 2. So it's bottom heavy, which means our asymptote, or our limit, is equal to 0. So we would have y equals 0 as our horizontal asymptote. Okay, so like I said, I do have a couple more of these planned. The one I have in class, we actually can reduce. So we'll see how you do that and what that means in terms of domain and vertical asymptote. But if you have any question on just the basic finding and what you do to find the vertical asymptote, the domain, or the range, come with those, and then we'll do the one where it's a little different in class. Okay, the second part of what we needed to look at today to help us with graphing was just finding the x-intercepts. And I know we've done this a lot, but when we get them into fractions, we sometimes start to get confused. So when you're finding x-intercepts or zeros, you want to remember that you set the equation f of x equal to 0 and solve. That's what it means to find the zeros. So on number 3, if we make 0 f of x and we cross multiply, so put 0 over 1 so that we can cross multiply, we get 0 times x plus 1, that's just 0. And then we get x squared minus 9. So what a lot of people will do is they just jump to this step here, because when you take the denominator and multiply it by 0, it's going to always be 0. So one of the tricks that people like to do is just take the numerator and set it equal to 0 in order to find the zeros, whereas the denominator we set equal to 0 to find the domain. So from here, we get x plus 3, x minus 3, So when we solve, we get x is equal to 3 and negative 3. So these would be my zeros for that function. So let's do number 4, and then like I said, I have another one in class that I want to do with you. So because it's just a fraction, when we plug 0 in for g of x, I can go ahead and jump straight to 0 equals 5x plus 3, because if I were to multiply 0 times my denominator, I'm going to get 0. So when I solve here, I'll get negative 3 over 5, so that would be my 1x intercept. Okay, so like I said, today we're all about finding these pieces. On the block day, we're going to go into finding and how they apply to the graph, so that we can sketch these types of functions as well. So if you have any questions on either the finding of the zeros or how to find domain, vertical asymptote, or horizontal asymptote, come with those and we can get those settled before we get into sketching of graphs on the block day.